Good day everyone, my name is BLESSY ATIS Ilajas from BSEE 1A, and these are my answers and explanation on how I derive my answers from the problem set given. So we are now on lecture 4. So the topic is conservation of energy, momentum, impulse, and collisions. So problem set number 1, check your understanding, 8.8 on page 374. How high above the bottom of its arc is the particle in the simple pendulum above when its speed is 0.81 meter per second? So, based on the given problem, our given is velocity is equals to 0.81 meter per second. So, in this problem, we are going to find the h or the height. So, dito na ta sa solution. So, from 0 is equal to the change of kinetic energy plus the potential energy, we arrive this formula. So, kani siya, Ki plus Ui is equals to Kf plus Uf. So, same sa previous problem, our Ki is 0. And we know nga, ang atong potential energy is equals to mgh. So, is equals to the final kinetic energy is 1/2 mv squared. Dayon, ang atong final potential energy is also 0 na siya. So, by manipulating this formula, so since ang atong gipangita is kuan man kanang height man, so ato siya ikuan na to i-over mg na to kay para makita ang h. So, makancel ang mg. So, na siya. Dili po makancel po ang meter. Blurred man eh. So, na siya. Dayon, so now, we arrive this formula which is, h is equals to 1/2 v squared over g or the gravity. So, by substitution the value, so, muna siya, 1/2. So, atong velocity is given naman. So, which is 0.81. So, kani siya, ato siya substitute. Dayon na 0.81 meter per second squared. Dayon, over ang atong gravity, which is 9.81 meter per second squared. Dayon, ato na siya is-simplify. So, 1/2 times 0.81 meter per second squared. So, is equals to 0.32805 meters meter squared per square meter per second squared over ang atong gravity is 9.81 meter per second. So ano siya, so i-simplify na nato, so i-divide nato ni, so we can now derive the final answer in which ang atong height is h is equals to 0.033 meter. So therefore mo ni siya ang kuan, ang katason sa bottom of its arc is the particle in the simple pendulum above sa katong nasa book, kung ang speed niya is 0.81 meter per second. So, atong height is 0.033 meter. And now, let's move on to the problem set number 2. So, example 8.8, page 375. Air resistance on a falling object. A helicopter is hovering at an altitude of 1 kilometer when a panel from its underside breaks loose and plummets to the ground on figure 8.9. The mass of the panel is 15 kilogram and it hits the ground with a speed of 45 meter per second. How much mechanical energy was dissipated by air resistance during the panel's descent? So, based sa given problem, these are the given values. So, ang atong m, which is ang atong mass, is equals to 15 kilogram. V, velocity, is equals to 45 meter per second. Tas atong yi, or ang atong height, is 1 kilometer. So, in this problem, we only investigate one body and ang gravitational force o ang air resistance is naa sila. So ang gravitational force is conservative. However, the unconservative force of air resistance does negative work on the fallen panel. So we can use the conservation of mechanical energy in the form to express by equation by equation 8.12. So find the energy dissipated. So in this problem, we are going to use the equation 8.12. And pangitaon na to ang energy dissipated. So dire ta sa solution. So muna siya atong pangitaon is energy dissipated. So dire ta sa solution. So the energy dissipated is equals to the absolute value of the non-conservative work is equals to the absolute value of the change in kinetic energy plus potential energy. So nag-arrive ta anhi nga formula. So kanina nag-arrive ta nga formula and ano nga formula, energy dissipated is equals to the absolute value of energy to the absolute value of kf minus ki plus uf minus ui. So as we all know, ang kinetic energy is equals to 1/2 mv squared. So kani siya ang atong kinetic energy is equals to 1/2 mv squared, and our potential energy, atong potential energy is equals and our potential energy is equals to mgh, tapos ang atong final kinetic energy and final potential energy is equals to 0. So kano siya dayon. So substitute the value. So kani 1/2 ang atong mass is 15 kg. So kani blurred na ni. Dayon ang atong velocity is 45 meter per second. So squared. Dayon ana siya. Dayon atong same na Japan dire. Atong mass is 15 kg. Dayon ang atong gravity is 9.81 meter per second squared. Dayon ang atong height is bantog na ko ano siya na 1,000 meter kay ato siya gi-convert kani siya 1 kilometer into meter. So mo nang na 1,000 meter. So mo na siya simplify. So mo na siya is equals to 15,000, the absolute value of 15,187.5 plus negative 147,000. Dayon is equals to pa siya simplify. Is equals to the absolute value of negative 131,812.5 joules. So kuan kanang wait lang. So after sa simplify, so using the scientific notation, we arrive 130 times 10 raised to the power of 3. So therefore, the energy dissipated is equals to 130 kilojoules. So nganong nag-wonder ta nga nawala naman ang negative. So di ba kadiri nawala naman ang negative. Kay kuan man kanang tungod siya sa kay kuan man absolute value, in which ang absolute value gid is positive gid siya always. So mo siya. So now the final answer is equals to ang atong energy dissipated is equals to 130 kilojoules. And now let's move on to the problem set number 3, example 9.1 on page 400 to 403, the Arizona meteor crater. Approximately 50,000 years ago, a large or radius of 25-meter iron-nickel meteorite collided with Earth at an estimated speed of 1.28 times 10 raised to the 4th power meter per second in what is now the northern Arizona desert in the United States. The impact produced a crater that is still visible today, in which makita siya figure 0.97 sa book. It is approximately 1,200 meter or 3/4 of a mile in diameter, 170 meter deep, and has a rim that rises 45 meter above the surrounding desert plain. Excuse me. Iron-nickel meteorites typically have a density of P is equals to 7970 kilogram per meter cube. Use impulse considerations to estimate the average force and the maximum force that the meteor applied to Earth during the impact. So, the given our initial velocity, ang atong initial velocity is equals to 1.28 times 10 raised to the 4th power meter per second. So, ang R sa meteorite is 25 meter. Dayon. So, atong density is equals to 7,970 kilogram meter per cube. Dayon. So, this given can help us to solve the problems. So, in this problem, we are going to find the average net force and maximum force that the meteor applied to Earth during the impact. So, atong pangitaon is ang average force ug ang maximum force. So, sa solution, so first pangitaon nato ang So, first pangitaon nato ang the average force. So, the average force during the impact is relative to the impulse. So, average force is equals to meter times change to the velocity over time. Dayon, the mass is equals its density and its volume. And based sa given problem, the density of meteors is equals to 7,970 kilogram per meter cube. Dayon, so the volume of the meteor, let's assume that the meteor was roughly spherical. So the volume is equals to P times the quantity of 4/3 pi r cube. So the average force is equals to the density times the volume times the change of velocity over time. Wait lang. So sorry for that. So density times the value of the volume of the meteorites. So kita na pa ako. So excuse me. So sorry for that. So P times the quantity of 4/3 pi r cube. Dayon. So the average so r cube times the final velocity minus the initial velocity over time. Now let's substitute. Ato ni siya i-substitute. So average force is equals to, so ang atong density is equals to 790 kilogram over meter cube. Dayon ato siya ikuan ang atong, so kani ang atong R is 25 meter. Dayon ang atong final velocity is negative 1.28 times 10 raised to the 4th power meter per second. So kuan man kanang nganong na negative ang negative 1.28 kay kuan man kanang ang meteorite is traveling vertically downward, so paubos siya prior to the impact. So that is why kanang the initial velocity is became negative. So muna na negative siya. So wana siya simplify. The average force is equals to 790 na siya simplify. So kana dayon mahimo siya 65,286.2 meter cube. Dayon kani dayon kuan na siya, so mahimo na siya positive kay kuan man times yung divide, same sign man, so same sign, add and keep different sign, subtract, keep the sign of the larger number and it will be exact. So sorry for that, happy lang Charlotte. So mura siya dayon, so ikuan simplify excuse me, so simplify. So after that, then the average force therefore the average force is equals to positive 3.33 times 10 raised to the 12 power Newton. So muna siya ang average force. So nakita na nato ang average force. So continuation, so since nakita naman nato ang average force, so pangitaon na po nato ang maximum force. So now let's calculate the maximum force. So the impulse is related to the force function by the integral of the maximum time and the initial time. Force function dt, so the force function is equals to the maximum force raised to the negative plus squared I, and the parameter that represents rapidly the force is 0 squared dt. So where the time is parameter that represent rapidly the force is 0 squared dt. Dayon so where the time is equals to maximum time minus 0 second. Na-blurred mo siya eh. So the final average is equals to 0.458 maximum force. So by manipulating, need na to i-divide both side ang 0.458 siya para makuha na to ang maximum force. So ato siya i-divide, so makancel na siya, makancel. Dayon, so atong average force ganina is 3. So di ba atong average force ganina is kani siya 3.33 times 10 raised to the 12 power newton. So magamit nato siya dire sa maximum force. So muna siya tong maximum force over then kanina tong average force 0.458, then i-divide na siya, so therefore our maximum force is our maximum force is equals to 7.27 times 10 raised to the 12 power newton. So muna siya ang maximum force, and kanipod ang kanang average force. So siya. And now let's move on to the problem set number 4, example 9.3 on page 406. Moving the enterprise. Mr. Sulu, take us out. Ahead 1/4 impulse. With this command, Captain Kirk of the Starship Enterprise on figure 9.11 has his ship start from rest to a final speed of final velocity is equals to 1/4 times the quantity of 3.0 times 10 raised to the 8 power meter per second. Assuming this maneuver is completed in 60 seconds, what average force did the impulse engines apply to the ship? So, gipangita ang average force. So, based on the problem given are the final. So, the final velocity. So, final velocity is 1/4 times the quantity of 3.0 times 10 raised to the 8 power meter per second. Dayon, ang atong initial velocity is equals to 0 meter per second. Dayon, ang atong time is 60 seconds. So, ang atong mass of the enterprise is equals to 2 times 10 raised to the 9th power kilogram. So atong pangitaon is ang average force. Ang average force. So, dito sa solution. So, gamito na to ang impulse momentum theorem. Impulse is equals to delta P. We all know that the impulse is equals to mass times the change of velocity. So, delta P is equals to equating this expression gives this formula. So, force times the change of time is equals to mass times the change of velocity. So, para makita na to si force, ato siya i-cancel. So, i-cancel na to ang time para makita na to ang force. So, since mo na itong gipangita. Di, so ang time makancel. Dayon, so now maka-arrive na din ta ani nga formula. So F is equals to mass times change the velocity over time. So then ato din i-substitute. So F is equals to nga atong mass is kuan man, mass of the enterprise is 2 times 10 to raised to the 9 power kilogram. So kani siya. Then ang atong velocity is kuan 7.5 times 10 raised to the 7 power meter per second. So over ang atong time is 60 second. So ana din siya i-simplify lang dayon, so i-divide. So we can now derive the final answer. So ang atong average force is equals to 2.5 times 10 raised to the 15th power Newton. So more to siya. So that's all. Thank you.